Welcome to the Lynx Technical Certification Program. The purpose of this video is to demonstrate how to test a 70-volt speaker circuit using the NTI-MR Pro test generator. This video is based off a test document called Speaker Load Verification Procedure that can be found in the test documentation folder. This new Lynx standard for verifying 70-volt distributed speakers will provide the service and engineering team with the following information. The field speaker wire has no physical damage such as frayed sheath or shorted conductors. The speaker circuit overall load impedance, measured in watts, falls within the expected range and does not exceed the amplifier's power capacity. Speakers are wired with correct polarity. Speakers are tapped at the same value, resulting with even speaker coverage and sound pressure level. Now let's get started with the speaker load verification test procedure. The first thing to do is disconnect the speaker wires from the amplifier, and verify the speaker labels match the test documentation and system drawings. The first test is called the ground fault test, where we can find out if there has been any damage to the speaker cable during installation. This photo is an example of how wiring can be damaged through excessive force on a wire pull. Another way ground faults can occur is a poorly terminated cable with a few strands of copper touching the speaker or metal enclosure or flex conduit. Using your voltmeter in the ohms mode, verify each speaker wire conductor has no continuity to electrical building ground. Electrical building ground can be accessed with any available metal conduit or junction box near your amplifier rack. Simply attach the first alligator clip or voltmeter probe to the metal and the other probe to a single speaker wire conductor. Remember, this needs to be done for each conductor while the speaker wire is disconnected from the amp. If there is any continuity between the conductor and building ground, the test result is fail. Continuity indicates the speaker wire insulating sheath is most likely damaged, and the bare copper is somehow touching electrical building ground by metal conduit or junction box. Troubleshooting this type of problem can be very time-consuming. This is why the installation crew should perform this test just after wire pull. Be advised, the old induction toner that everyone likes to use will not tell you if there is a ground fault, nor will it measure any of the other tests in the new Lynx testing standard. We do not recommend using this tool for speaker testing, as it tends to give misleading results. The next test is to measure the speaker circuit load, but first we should make sure the test generator has spare AA batteries, and you are using the NTI fused XLR test leads. This cable has useful alligator clips and will protect the generator from accidental high voltage spikes and current flow. Power up the test generator and navigate to the impedance menu. Make sure the measurement is set to power, which gives you the impedance measurement value in watts. This is simply calculated using Ohm's law. Make sure the reference is set to 70 volts. The impedance test signal is a sine wave that can vary in level and frequency. For now, let's use the -10 dB line level at 1000 Hz. Remember, a speaker level signal is not required to measure speaker circuit impedance. If someone changes your settings, or you can't remember your settings, this impedance configuration can be stored and recalled as a preset in the config menu. The next step is to connect your test leads to the speaker circuit. The -10 dB line level sine wave applied to a loudspeaker will not be very loud, but you should hear the test tone if you stand next to the speakers. Notice the power value is shown as letters VA. This stands for apparent power, which is defined as the total power in an electrical circuit, including both the active power and the reactive power components like a speaker coil. For simplicity, we will document this value in watts. You can document the power values by writing this down on the test document or taking a screenshot of the test generator. To take the screenshot, press the on-off button and enter button simultaneously to store the screenshot in a folder called Screen. The test document should be prepared by the project engineer or field engineer before you begin. This document can be useful for showing user-friendly zone names, speaker wire labels, and expected load, which can help flag potential installation issues. Now you are ready to measure the speaker load for each speaker circuit. Simply connect the test leads to the speaker wire, then record the value to your test documentation. Each test measurement kit includes a Neutrik female connector, so you can easily connect to the male Neutrik connector of the speaker circuit. After the impedance measurements have been taken, connect the speaker wires back to the amplifiers. If this is a new installation and you are the foreman or install technician taking measurements, you can assign the field engineer to finish the polarity and tap check during their commissioning. The polarity and tap check can be simple listening tests after the system is up and running. Play a familiar music soundtrack at around 75 dB, normal volume on each zone. While walking in the speaker zone, listen for sound pressure level differences between speakers to verify they are tapped at the same value. Noticing the level differences can be tricky, and it may be necessary to play back pink noise instead of music. With pink noise you can walk the zone using the NTI XL2 sound pressure level meter. If a speaker is noticeably different compared to the rest, then most likely the tap value was set incorrectly. The polarity check is similar to the tap value check. First, inspect the red and black wiring at the amplifier outputs for any mistake. Then, play a familiar music soundtrack and walk the zone, listening for missing bass frequencies under each speaker. If bass is missing, the polarity is most likely backwards for that speaker. Again, detection can be subtle, so take your time while walking each zone. For consultant bid jobs, it is recommended to use the NTI polarity test track and the NTI XL2 to verify polarity. Play the polarity file, and use the NTI XL2 to pick up the polarity pulse signal coming from the speakers. Positive indicates you passed the polarity test. Here is an example, speaker load verification form filled out. Let's find out what we can tell from these results. The Zone 1 measured value is 87 watts. This looks normal. Remember, the measured values can be up to 20% off, in some cases. The reason for this is that impedance value will depend on the frequency, wire gauge, wire length of the speaker circuit. The Zone 2 measured value looks normal. The Zone 3 measured value has a problem. The measured value is approximately double the expected value, so, I will assume the installer tapped the speakers at 30 watts, instead of 15 watts. The Zone 4 speaker circuit has a ground fault problem and the measured load exceeds the expected load by quite a bit. The note says the audio sounds distorted, which is a common feature of a ground fault problem. The Zone 5 shows a failed polarity test at speaker number 27. All these problems are rare if you follow the best installation practices and double-check your work. This report will help the field engineer, service manager, project manager plan out the best solution for the repair efforts. I hope you enjoyed this video, and you are better prepared for installation and testing.